Hey guys, Bart from TST Industries here. Welcome to TST Garage. In this video, I'll be walking you through the installation of our load balancing resistor kit on just about any modern motorcycle. Now, if you're asking yourself why you need these parts, well, maybe you don't. If you've changed your signaling system from the OEM incandescent light bulb type to an aftermarket LED type, which includes either standalone pod signals with LEDs for their light source or an integrated tail light that has signals integrated into the capsule of the tail light, those components draw much less current than the OEM incandescent light bulbs do, and they will throw off how your signaling equipment works. This is because your OEM relay is a current metering device. It will send the cycle down to the signal lamps, turn them on, sense how much current goes through, shut it off, and then the cycle begins again. If you're drawing much less current than the OEM prescribed, now it'll go off into a different cycle. It will either flash very fast, and we call that Hyperflash, or like on Honda Groms and some other bikes, it'll just stay on. It just doesn't disconnect at all. One way to circumvent this problem is to add extra current to each signal lamp, which means for a pair of 2 signals, you would need 1 kit of these resistors. They come with their individual connectors and they come for a set. So you have left and right for the front. If you're doing 2 signal sets, front and rear, you would need 2 of these kits. We also produce LED flasher relays. They are technology that is meant to replace your OEM relay, and replacing it with ours, and that cures your problem, sets it back to 85 cycles per minute. No big deal. These relays also enable you to adjust the flash rate. The cap on our relays just comes off. You leave that plugged in. You move this potentiometer counterclockwise or clockwise to speed up or slow down the flash rate to your liking. Then you replace this on the circuit, plug it back in, all good to go. Now these take very little time to install. We carry a vast array, as you can see, from many different bikes. We have the solid state electronic version. We have a resistive version that is also plug and play. There are many reasons why these don't work on certain bikes. That's why we developed these for very specific bike models. I won't get into the details here. I just wanted to touch on the fact that there is another option, not just the resistors, and these are all plug and play, and they're very simple. You don't have to manage any heated elements that are dangling around. You don't have to tie them off to the frame. Whereas with the standard resistors, we will have to do some of that, and we have to take into consideration some of those parameters, and I will talk about that a little bit more in our installation flow. Our resistors currently come with printed instructions. They are pretty concise, but there's a lot on here, and I just wanted to make a video for you guys to just follow along step by step and understand each step properly, and that way I can enable you to do this at home with very basic tools. So we'll get into that, also show how easy it is to install one of these on the harness I'm going to be showing this installation on. That way you could evaluate both flows and see what's right for you and choose that and go to tstindustries.com and make the appropriate purchase. All right, let's get going. My presentation here will be split into 2 segments. First one being on the table here using this harness that I've stripped down to only the components and branches of the circuit that we will be considering, thereby making this a universal description that can be applied to any bike or any 12-volt system vehicle out there. Our second portion will be on a Honda Grom. I just chose the Honda Grom because it's small, it's easy to deal with, and I have one laying around here. So there I will describe to you how to perform the rest of the installation beyond just electrical connection, how to hook things up, how to select where to hook things up, things like that. So we'll move on to that next. First, let's deal with what we have on the table here. So you can see we have a power source, 12-volt battery. This is a typical bike 12-volt battery. In a car, it'll be much larger, but this is what we're using here. We have our control that turns on and off our signals. We have front signal, rear signal, and we have a tail light. The reason why I'm using a tail light here is because many people opt for an integrated tail light that has signals in the capsule. I will demonstrate what happens when you connect one of these to your signaling system. All right, let's fire this thing up and simulate the problem that we will be facing. This is a fully OEM built setup. You have incandescent light bulb, and then you also have your stock signaling relay. This relay is set to 85 cycles per minute flash rate, but as I said in my intro, when you decrease the current draw, now this thing will be tripped up. So let's simulate that. Let's take this out. On most vehicles, you only have to replace one of the signals with an LED signal that draws much less current to trip up the system. On some of the bikes, like I mentioned, it'll go into Hyperflash. Some of the bikes, it will actually get stuck on. On the Honda Grom, it gets stuck on. On this bike, it flashes fast. If you compare this to the previous rate I showed you with the stock signal, this is much faster. The less current you draw, the faster it gets. So if we replace this with another LED signal, it'll go faster. Now, a similar thing happens when we replace the taillight and plug in the taillight signals. Let's put this to the side. We'll bring an integrated taillight into view here. This taillight uses LED lights as the light source, so stands to reason it'll also hyperflash. As you can see, it is flashing faster than the 85 cycle per minute rate. Again, if we unplug this, plug in an aftermarket signal, it should go up in rate by just a little bit yet again. Not much of a difference from before, but it is flashing fast. So what do we do now? Well, let's briefly talk about where we want to tap these in. They do need to go and get wired parallel to the circuit, which means one to ground, one to the positive, making it kind of like a ladder setup. So do we really want to hack into the OEM wiring? Well, it may be easier on your particular application, so you may have to splice into here. I typically like to go with making connections to the aftermarket components because sometimes I want to restore the vehicle to its OEM state, and at that point I want to leave no trace of aftermarket components being installed on the bike. So I typically make my connection of these types of components into the aftermarket branch here. So I've chosen this area of wire to connect my resistor into. These components are not polarized, so whether you connect it this way or this way, it makes no difference. These connectors here have a piercing element and a shielding element. This piercing element has scissor looking geometry like this that is meant to go around the wire like this, pierce the insulation, and make a connection on the wire itself within this insulation. So each one of these connectors will receive two wires through it, one of the signal wires and one of our resistor wires. Now we do have slots within these connectors that the wires are supposed to be housed in. I'll make that illustration in just a moment. One hole, other hole. So we want the wires routing straight through the axis of these holes. That will make sure that our piercing element goes right into the insulation of these two wires and connects them properly. Here on this side, I like to make sure that I almost penetrate with the resistor wire. I just retract a little bit. I don't want that hanging out and being able to possibly connect to something else, frame or otherwise. And then once I have my wires positioned properly, I press down using pliers on this piercing element until I get it to bottom out. Now this is usually where I see most of the people out there making these installations having the problem. The piercing element does not effectively pierce through the insulation, and then you have an issue. So what I like to do is make this connection, close the cover on it, that protects it from opening back up. I'm going to make the other connection, and we're going to go straight into testing. I'm going to test and make sure that we made that connection. If not, this is the perfect time to redo it. I'm going to repeat the steps on the other wire. Again, I want to keep this wire from penetrating all the way out. I want to have it shielded. The other consideration here is if you put these in the same exact spot next to each other, now you're creating a lot more bulk in one area. What you can do is stagger these like this, and that's what I'm going to choose to do here. When we stagger them, we could fold these wires over each other, and then they'll still be nice and neat here, but then we will have less bulk to distribute here in this area of wire junction. Get my piercing element to pierce those wires. Make sure it's bottomed out. Close the cover, and let's give this a test. We are back to 85 cycles per minute. All right. On this particular bike, with this particular flasher relay, it is enough to wire in one extra resistor in a side of the signaling system to restore proper flash rate. On some, you will need one on each of the lamps. All right, so the electrical connection of this particular leg is done. We are tapped in. This is all good to go. We've verified that it's working. Now what? We would have to find a place to tie this resistor off to the bike where we are not coinciding with any heat sensitive components. So you don't want this thing touching your fairings. Fairings are made of ABS plastic, and typically they have a certain amount of heat capacity that it could take before they melt. These, if they are left on for a very long time, they do get quite hot. So we want to make sure that these don't dangle around and touch things that may melt. Another consideration is if these are not tied off to some rigid component holding them in place, you will have these dangling around, and as you ride and encounter speed, vibration, bumps, things like that, this will work back and forth, and at some point it'll either break one of these wires or break the connection from our electrical connectors. So we want to make sure that this is tied off on the bike somewhere away from heat sensitive components, and then that'll be that. So let's now grab the bike and bring it in frame, and there I will show you guys what to do about the physical arrangement of these components for success. Let's get that done. Okay, so we have a bike here that demonstrates the symptom of just having the signal stuck on after replacing the OEM signals with LED type aftermarket signals. Here you see an LED taillight that has the signals in the capsule. You can tell it's not flashing. The relay on this particular bike is right here just aft of the battery, and we happen to make a replacement for it. I removed the OEM and I replaced it with our LED flasher relay, and boom, there you go. Problem solved. It's as easy as that. It's OEM replacement. It hangs in that original hanging place. It's really the simplest way to go. But we are here to talk about how to install our resistors. So I'm going to put it back to stock. Again, it's stuck on. Now we just need to consider where to make our connection on this particular bike, and we're going to talk about the strategies that drive where I like to mount these things. And then physical mounting will have to be considered also, because if you're going under the seat here, you need to make sure that if you're tying off to the frame, you stay away from areas where the seat may rest on the frame. So this is out, this here is out, but all of these components here are pretty good just from the side. I think I like this area here on this frame component from the inside or from the outside. If we have space, we have to make sure that this area is clear so that the hooks don't damage our resistors. So those are the considerations we have to make. Each bike's going to be a little different. Now we're talking about a subframe section here in the tail. Now in the front, you will likely be going under some fairings, under a headlight. So similar considerations have to be made, just catered to that particular area. Those are all very simple things, so I will not dwell on the detail too much. Let's find the signal wires. On our taillights, typically the positive wires are brown and green for each left and right signal, and then black is the ground. On our signal sets, with our harness converters that make the signals plug and play, we typically use yellow for positive and black for negative. There are some other combinations of wires that we have for 3-wire signals. You can read about those on our website. If you're buying any of this stuff or making the installation using aftermarket components that are not made by TST Industries, you will just have to figure out which one's positive, which one's negative, and then you'll be good to go. Now, for us, the only reason it matters which one's positive, which one's negative, is because we don't want to hook up our resistor between the positive and positive of the signal leads. That would just yield poor results. So what we'll need to do is tap into one of the signal positives and the ground, and then with the other resistor, go into the ground again, and the opposite end will tap into the other signal that hasn't been installed into just yet. All right, before I start tapping and commit to my positioning, I have finite amount of wire that I can move fore and aft, left to right. So let's make sure that we will actually physically fit in here without any adverse effects. I think this will work here. I am touching the frame, which will wick away the heat. I'm not touching any of the plastic. I can actually get 2 of these in this area, one on the inside, one on the outside of the frame. I'll use some wire ties, some zip ties to get this cinched down. I do believe that my hooks will clear all of this. Yup, that's looking pretty good here. So now I'm going to commit to this area. I know that I can reach these wires here, so no big deal. The strategies here are basically, I'm describing a generic strategy. You will have to adapt this to your particular bike. But at this point, it's pretty easy to do. I'm going to unplug this just to make it easy for me. So I've got all the wires that I'm considering tapping into on the inside of the trunk space here. Let's go ahead and grab one of the connectors, get my ground wire into the appropriate slot here. This may be a little cumbersome, like you see here. Make sure that my entire wire is on axis with the hole. I'm going to grab the resistor and get it into that other hole. Press down on my piercing element just a little bit so that I have a captive system and I don't have to worry about things coming apart on me as I manipulate this setup. I'm not going to press down all the way just yet. I don't want to pierce it. At this point, I'm just going to validate that I have enough wire length here to still make my connection proper and be able to manipulate this element here within the trunk space to put it where I want to mount it later. All right, so that's looking good here. Let's go ahead and lock that down. Okay, I'm gonna grab another one of these connectors, and at this point, grab one of the signal wires, it doesn't matter which one. Get the other side of that resistor, get it placed on axis, tighten it down a little bit so it's self-captive. Again, checking that I have ample length for manipulation. It's looking good. Make the connection. Let's give this a test. I did disconnect it, so I have to reconnect it. We have flash rate, good to go. All right, I'm gonna back up one step here, disconnect this back up. I'm not going to narrate the next set of steps because it's the repeat of the steps I just performed here, but with the other resistor. I actually have decided to run both of these on the inside of the frame because it's going to be vastly easier. All right, so we've made our electrical connection. Let's give it a test. Both sides are working as intended. Shut it down, and at this point we will need to neaten all this stuff up and get it in place, tie it off to the frame. I've already picked out the area where I'm going to be tying it off to. Grab a wire tie. All right, let's see if we can still get our seat on. I don't think I've obstructed any of the latch components. It's all looking good. Okay guys, that's pretty much it for the instructions. I just wanted to touch on a couple of frequently asked questions and answer them in this video so that you guys have the info up front. One of the questions we get is, can you use the relay, an aftermarket LED flasher relay, along with the resistors? That is a redundant installation, and furthermore, the upped current draw using the resistors may damage the relay. I advise against it. Each one of our resistor kits comes with a warning label. You actually have to get through it to get inside the package. Please read it. It does instruct you not to use these in combination. The other question we get a lot is how many resistors or relays do you need to fix a fast flashing signaling system? Well, with resistors, like I mentioned before, you will need at least one per signal side. In some instances, you can get away with only one added extra leg of resistor per side of signal. Sometimes you will need one on each lamp. That is determined by the type of vehicle you have. I can't tell you up front, but you could start with one and then move on from there. With relays, it's really just the one relay. You take out the OEM relay and replace it with our LED flasher relay, and then you're done. Third question I hear often is, does fast flash rate damage anything on the bike, any of the circuitry? Well, the answer is no. The lamps don't care how fast you actuate them or if you keep them on. What you want to do is be visible to the traffic around you and not be confusing. So typically people opt to stay with the 85 cycle per minute rate or something close to there, and that is achievable like I showed you with the resistors or the relays. So that's that. Thank you for watching. If you need the resistors or a relay or any of the other parts that I've showcased in this video, check out tstindustries.com. We have those things always in stock, ready for you to purchase and get delivered to your door and installed on your bike. Furthermore, we pretty much have installation instructions for every part that we produce, so check that out. Thank you for watching. Ride safe. See you later.